Hi, my name is Ken Ramsley, and today I'm going to talk about replacing the switch that controls your spa that's part of your swimming pool system. And what I mean by the switch is this 4-button device here typically allows you to turn the spa on and off, the heater on and off, the light and air blower. Different pools may have different controls, but this is the standard setup. And typically the switch is located within reach of the spa so that you can make adjustments while you're in the spa. Now, of course, the first question is, do I really need to replace the switch? And ultimately the answer is you'll start seeing certain controls switching on and off all by themselves. For instance, we noticed that the heater was coming on and off all by itself. The blower was switching on and off all by itself. So you can imagine you come home at night and all of a sudden you hear this thing coming on and off. This is the air blower for the spa. And in our case, it was cycling on and off about once every second. So we have something called ghosting, according to Jandy. They call it ghosting. It's as though a ghost is pressing all sorts of buttons. But that doesn't tell you what the problem is. Inside the panel here, there's a computer and memory and so forth. So my first suspicion as an engineer was I thought maybe the software was starting to lose bits and the control system was going on the fritz and I might need a new control board. I called up Jandy and they said, well, most likely it's the switch. And so I asked them, well, how can I tell if it's the switch? And they said, all you have to do is unplug it from the control board and you're all set. If the problem goes away, you know it's the switch. Okay, so that's the first thing I'm going to show you. Before you do anything, this is how you can tell whether or not the switch is your problem. So the first thing I want to do is take the panel, the front part of this panel off. There's 4 screws. There's typically 4 screws, and just pull that off and you'll be able to see everything you need to see. Before I do anything else, the first thing I want to do is I want to switch off the power. So I'm just going to switch off all of the circuit breakers. So let me get that panel off and I'll show you what's inside. I also noticed that I need to take off the cover that covers the 9-volt battery. Okay, so I have the screws out. I'm just going to take the panel out. This black connector right here, that is the connector that goes to the spa side switch. Now it's important to make a photograph, maybe with your cell phone or whatever, because the color sequence of these wires will be important later on when you're wiring up your new switch. And you see these little screws here? That's for taking the wires out of the connector, but at this point you don't need to do that. Let me see if I can do this with just one hand. Get a little screwdriver in there and I'm just loosening it a little bit. It's really basically just finger tight. You can kind of work it out and out it comes. Okay, so now you're disconnecting your switch. Now at this point I would say you're done for a couple of days. What you want to do is you just want to tuck this thing out of the way, put the panel back on, use your pool as you would normally use it, and if the ghosting stops, well, now you know that it was the switch that's the problem. And if it turns out that the switch assembly next to the spa is your problem, if that's your problem, by unplugging this connector here, the problem should go away, and that'll tell you that that assembly, the switch assembly, needs to be replaced. If you continue to have ghosting, then it's something else, and you're going to have to watch a different video. The first thing I want to show is the condition of these buttons. The camera is about 1 inch away from the buttons, and you can see that after 15 years in the sun and surviving the winter or whatever, the quality of the rubber looks like it's in pretty tough shape. It looks like it might be cracked. And that's most likely the root cause of the problem. Okay, so here's a brand new switch, and you can see the condition of these buttons are very good, obviously. And you see another thing that they're doing, that this black material, that's called potting, epoxy potting, and they pour that inside the entire assembly to seal it off. And in fact there's this rubber O-ring right here that gets pressed inside the conduit that this thing sets in. And what they're trying to do desperately is to keep moisture out of the system. Now, of course, if things were broken and water floods in, that's an obvious way to short out a switch. But over time, if you have degraded rubber buttons, what will happen is even with a very small crack, these things will breathe. When they get hot, the air pressure goes up, so it pushes air out, and at night they get colder and the air pressure drops, and they'll suck in whatever air is there, and at night the air tends to be damp, and over a long period of time, if there's any kind of defect, any way for this water to get in, it will, and it will accumulate and eventually short out the switch. Okay, the other two pieces of the kit are you get a brand new connector. Why not? You could probably use the old one, but why not? You have a brand new one. And this rubber seal, which you'll thread the entire length of this cable all the way up and put as a collar right here. So you want to, basically it's just an additional seal to try to keep water from flooding from your deck into whatever hole is there for the switch. Now the question is, why not just cut this wire and splice it in? Why go to all the trouble to try to snake wire all the way back to the controller? And the answer is simple. You are having a battle with moisture, with moist air. Now if you have rotten buttons, that's a pathway for moist air to get in. Or if you cut this cable right here and splice it with electrical tape or just about anything you can imagine, you're going to leave a pathway for cool moist air to be sucked into the switch every day until it fails. Now when I read online about people splicing in the wire, they say, oh, it saved me so much trouble rather than sending, trying to fish this cable all the way back to the control panel. Okay, well I get it. It saved you trouble, except that it fails in 2 years. 2 years down the road, 1 or 2 years from down the road, a splicing repair will fail. So don't cut the wire. Do not cut the wire to splice in a new piece. You need to thread it all the way back to the control box. Okay, my plan is to take some of this rope, have it run alongside this cable, and then wrap it tightly in wire, really tightly in wire, maybe 20 or 30 times, something like that, and then wrap that whole thing in a layer of tape. This is white duct tape, and in order to have something that's really well connected together, and the tape will keep anything from sticking out that might catch. But first I have a problem. I have button numbers, but I don't know what they control. And I have a place to put labels, so I want to associate those button numbers correctly. Well, there is a way to do that. What I can do is I can connect this thing up temporarily in the right order, the same order of colors, wires that I'm seeing in the panel, plug it into the panel, and then press these buttons to see what happens. Then I can label this thing and know that when I put the assembly together for the last time, everything should line up. I took a picture of the connector as it's wired up in the panel and wrote down the names of the pins, the numbers of the pins, and each color associated with it. I strongly recommend that every step along the way you take lots and lots of pictures. Later on you can always go back after you've done something to see how it should have looked like when you're done. I'm going to wire up the end of the cable as it is to this connector, plug it into the system in order to figure out what these buttons do. Okay, specifically what I do is I take the wire here and twist it just a little bit, just to get all the little individual wires into a bundle. Okay, I'm going to leave the camera just pointing at what I'm doing, and so you can see what I'm doing here. I'm going to put the wire in the gap, in the well here, call it the well. Just going to hold it in place, and then the screws here, and you just turn the screw until it's like a little clamp. It just, when it hits the bottom, it'll just clamp those wires in really nice and snug. Okay. Alright, so we have this connector that's still disconnected. We've pulled the old switch out, and we have this connector going to the new switch. I've got my new connector, my new cable, my new buttons plugged into the panel. The panel is currently off, so what I'm going to do, even though it's not recommended being an electrical system or whatever, but if you just stand back, no kids around or whatever, you can turn on the panel, power it up. Okay, everything's there. It turns out that you have, in order to do testing, you have to do this in auto mode. Service mode doesn't seem to work. Maybe for obvious reasons you're not going to be fiddling with that switch when you're in service mode. Okay, so the question is which button is which, and so what we're going to do is currently the filter pump is running. It's programmed to be running this time of day, and let me try out this this button. Let's see. Button, it just happened to notice that button 3 turns on the blower. So button 3 is the blower. Button 4, according to the panel here, it's the spa light. And button number 1 turns the pump on and off, or goes into spa mode or not. Let me see here. Yes, currently, although it's hard to see, we are in spa mode, so that's button number 1 to go into spa mode. Or pool. It actually cycles between spa mode and pool mode. Okay, and then therefore we have one button left to go, and that's number 2. Button number 2 should turn on the heater, but it's not going to do that until the pump is going. Okay, well, it just takes a minute for things to switch over. I keep forgetting that. So when we went into spa mode and heating mode, all the valves had to reposition themselves. And now it's in spa mode, and it is now calling for heat. So now I can apply my decals and move on to the next step. So before I forget, let me just write this down. Button number 1 is spa. Button number 2 is heat. Button number 3 is blower. And button number 4 is the lamp, the light. Okay, so that's 1, 2, 3, 4. Okay, so now I'm ready to apply decals to the switch. Okay, now this. I need to label the switch. And here's my instructions, freshly retrieved from the spa, courtesy of the wind. And I'm using pliers, just, because they're not greasy. That's the only reason. Otherwise, I would just use my fingers. But grease and adhesives just don't cooperate very well, and I want that label to stay on there for a long time. Okay, and I've just got the corner of the label, and I'll pull it up with the pliers and stick it on the switch. Okay, and here it is. I've laid it in. It's just almost exactly the same size as the opening, so you need to get it right into the corner there, and use the pliers to press the adhesive together. Use the round surface, don't scrape it, of course. And then the back of your fingernail at this point is probably fine. Okay, so that's one, and I'll do the others. Okay, and there are all 4 labels. And as long as I wire this up correctly, the right colors into the right pin numbers of the connector, these functions should work correctly. Well, I'm waiting for the spa to shut down. It takes a little bit to go through a cool down cycle. Let me pry the old switch up and see what we have. This has been here for 15 years. This RTV. So we'll see what we can get. I assume even RTV dries out after a little while. Rubber cement, caulking, whatever. Hopefully this will come up without too much trouble. Okay, well, let's get a bigger tool. Yeah, it's loosening. I'm hoping that there's extra cable for play, so they didn't pull it tight. That would have, but there is extra cabling inside the panel, so even if I need a little bit more play, I should be able to pull the thing out here. It's really important to kind of work this out carefully. Don't want to break the patio. Okay, well, I'm gradually working my way towards getting this out. I don't know, I just have a habit of taking my time when things are a little bit resistant. Don't want to, I don't know, I'm not sure what could happen. I could break it somehow, but just gradually work it out. It's kind of coming loose now. Alright, there we are. There it is. There it is. In fact, Put some goo, and you can see the seal. The seal goes in. Oh, okay. All right. The conduit's actually pretty big, or at least this particular piece here. Okay. So this is a collar that goes onto the conduit, and then this, well, this probably isn't doing any good because it's down below the level of the collar. So this collar is sandwiching around the neck of the switch here, and that's what's actually doing the seal. They added this material here. I think this collar's just fine the way it is. I think I'm just going to leave it. I'll just reuse it in place. There's no sense in pulling it out and trying to seal in a new one. The same thing for this material, almost like insulation jammed in around here. Yeah, they really, when I put this back together, I'll probably put a thick bead of RTV around this collar just to try to keep water, you know, people from splashing, whatever. I just don't want a lot of water in this area, even though the whole thing is sealed up. The switch is sealed up, you know, ice damage or whatever. Okay, so that's where I am right now. I've gotten this thing out. There's a little bit of extra cabling. I'm not expecting a lot, but that's fine. That's what what I'm going to do is I'm going to attach the rope to the other end of this cable. So when I start to pull this out for real, I will pull out the cable, then I'll pull the rope through the conduit. And hopefully nothing will catch on the way through. Okay, this is just my work site. And there we are. Soon to be replaced. Alright, so now the spa has shut off. I could pull this connector out of the panel again, and I don't need this connector right now. In fact, I don't want to try to thread this down through the conduit, so I'm going to remove these wires. Okay, same as before, except it's a little easier. Just a couple of half turns for each one of these. That's enough to loosen it up. And actually what I'll do is I'm going to screw them pretty much all the way out to make it easier the next time around. That's a good idea. I'll just pull them up to the surface of the connector here. Okay, this is called Titan paracord, and it really literally is the same rope that's used to attach parachutes to harnesses. I can't remember the rating, but it's several hundred pounds. I was looking for something that if I yanked on, I wouldn't have to worry about breaking the rope or breaking the string that I'm using to pull things through. Obviously overkill, but it'll come in handy for other uses, I'm sure. Alright, here's the old connector. When you put your assembly back together, you want to have a lot of free play in the cable, just because. If nothing else, when you're going to end up cutting this cable, stripping the wires, and there's quite a few wires here, and if you mess it up, you're going to lose 2 inches of cabling. So just having lots of extra play coming through here is a really good thing, and I'm glad they did it. Of course, a question is, where does this go? And if you follow the cable through, you can see down in here that it goes to the top of this conduit connector, Romex connector, and that goes down through this pipe right here, So the conduit I keep talking about, I kept thinking it was this flexible conduit. It's actually PVC pipe. It's PVC pipe, and hopefully there's no bends, serious bends that'll get things caught. That's one of the reasons why I'm using rope, and I'm going to tie the cable to the rope with an extreme amount of effort, which you'll see in a second. Alright, the first thing I need to do is remove the connector, because obviously that's not going to go down through that pipe. So, same as before, you just unscrew these screws, and that loosens the clamp on these wires, and you just pull the wires out. Okay, so now I have this long cable. It just terminates in wires, and what I'm going to do is dedicate at least a foot of this to an interconnect between my rope and my cable. I really want to lock those two together. So first thing, I'll get the rope out. Alright, I'm not going to need all of this rope. This is 100 feet of cord. The conduit is probably no more than 50 feet long. But the key thing is it's all loosely laid out, so when it starts to go down the conduit, it won't bind up. There won't be any knots or twists or whatever, kinks. Okay, so what I've done is I've just temporarily tacked the two together in parallel. Okay, and I have this wire. It's really stiff wire. I'm not sure what kind of, I guess I'd call it baling wire. It's stiff, it's malleable. What I'm going to do is I'm just going to wrap it around both of these, really, pretty tightly. I mean, not so tightly that I break the wire, but really tightly. Okay, so I didn't wrap it like constantly, like a thorough, complete coil. I still want there to be some flexibility, and there is, so it can actually work its way down. Okay, so here's one end. I just have the wire pinched, and it goes just, you can see the way I've wrapped it. Here's some white duct tape. It just happens to be white. The silver duct tape works fine. And I'm just going to wrap the exposed wire with this. Hopefully it won't make it too stiff. We'll see. Okay, well, I've just sort of wrapped it the best I could with fingers and the old-fashioned way of wrapping tape. And I figure the sandwich between the wire and the tape and everything, hopefully that will kind of add up to some really good solid strength. Now hopefully I should be able to pull this a little bit. Oh yeah, we're getting a little bit. Okay, that's probably about the beginning of the tape. Okay, and this is right where it stopped because it was trying to get around this corner, so let me feed that in a little bit. Okay, I'm at this side, and I'm going to just give it a kind of I don't want to break this cable either. Okay, it does not want to move. Alright, that's a problem. I was wishing this was just ordinary flexible conduit as opposed to this PVC stuff, because it's going to have to go around corners. So I think my splice is a problem. Well, my first experiment didn't work. The wad of tape and wire and all that stuff was not going to go down the conduit. So plan B is when I cut that mess off the end of the rope, I discovered that this rope has a sleeve that goes around about a half a dozen very strong nylon threads. And so what I'm going to do is I'm going to individually tie these onto a loop of wire, and then I'm going to do a little bit of wiring onto the cable and a little bit of tape, but a much, hopefully much less of a mess to try to feed through the conduit. I got to keep the profile down, and I also have to sort of have an elbow here so that it bends going around corners. Okay, I've tied these individual strands onto the end of a loop of wire. Okay, I've taken that wire that I showed you and wrapped it loosely around the cable, wrapped it pretty tight, a couple of tight turns right here, and then taped it in little segments so there's a little more flexibility maybe, I don't know. I grabbed both ends of these and yanked it as hard as I could, harder than I would dare pull on the cable itself, so it came a little bit loose, so I tightened it up and played around a little bit more. And I gotta tell you, this is not something I would ever guarantee, and I would rather they had put in a straight shot of conduit as opposed to jointed PVC, but that's what I get. So I'm going to repeat my test now to see if this will snake down this conduit a little bit without having to get a hydraulic lift to pull this thing through. If I can't do this, then I'm going to have to find some sort of electrician who knows how to feed stuff through conduit, because this is the best I'm going to do. Well, the first thing to show you is I've looped the rope over here so it feeds straight down into the conduit. Once I got past that initial shoulder right there, it seems to be feeding okay. So I'm gonna show you on the other end. You can see I've already pulled out quite a bit, maybe 6 feet, and I wasn't pulling that hard. I was just kind of pulling away, no problem. Just nice gentle pull. Hopefully I won't hit any corners. It's getting a little stiffer, but still coming along. Very nice. It's wet. The cable is soaking wet, which I'm not surprised because that stuff just gets into pipes. Coming even easier. Thank goodness. Thank goodness. I don't think I've broken anything off. Probably got 30 feet out by now. Oh no, come on, keep going. Yep, maybe 40 feet out. Another 5 or 10 feet to go. Keep coming, baby. Didn't think this would happen. Alright, keep coming. It's gonna run out eventually. Yes! Beautiful! success. Awesome. I'm so happy. Alright, so now we have a conduit full of rope, but that's what I want, because that rope is going to do the job of pulling the new cable back down through. Okay, way over by those towels, I have the new and the old switch pinned into the fence, and I've stretched the new and the old cable all the way, about 60 feet I think, until I get to the end of the old cable. Okay, so they send along 100 feet of this stuff, and even though I could pull all 100 feet through, I've decided, okay, well I'll be charitable, I'll make it like 4 to 6 feet longer than the old one just to have some slop to play with, and I'll just cut off the extra. I'm a little nervous about that, but I'm going to have to cut it off at some point, and I may as well do it now before I go to the aggravation of pulling 100 feet of this stuff through the conduit. Okay, so these are the two ends. There's no kinks. All the way back. Okay, I'm going to grab this, and then I'm just going to pull another good number of feet extra just to make sure. And I'm really kind of nervous. I'm going to pull a good 8 feet extra, and then I'll cut it right here. All right, here we go. Cutting about 6 feet longer than the old cable. I got to tell you, this is the scariest part so far, but the deed is done. Okay, here's the end of the rope with its wire harness, mechanical harness attachment, and I'll just do what I did in reverse. I'll give it a really good test before I send it down that pipe, and I'll just sort of do in reverse what we just did to get the thing out. Okay, the wire here is still, these individual strings are tied to the end of this wire, and then I've kind of loosely wrapped it around the cable, and right here, I just want to show you before, I wrap it really tight as a collar. That's about it, and then I'm going to put little segments of tape here. Hopefully it'll be just as strong as it was the last time. Okay, it's all nice and crimped at the end, a little bit looser on the middle part, and these threads are tied to a loop at the end. This is all one piece of wire that bends and loops starting right where my fingers are. So I'll put a couple of segments of duct tape just to kind of keep things from sticking out and add a little bit of, additional connectivity, trying to keep this thing all together as one unit. And then I'll do a pull test, pull it as hard as I feel comfortable pulling it harder than I would pull on the cable. Although at this point, if I'm halfway through and it's stuck, I'm not sure what I'm going to do. I'll probably, pull from both ends to kind of loosen it up or whatever, but I'll cross that bridge when I get there. I just wanted to point out that this grommet right here, this seal that comes with the kit, if you're replacing that, you need to put this on this cable before you attach the rope. I just wanted to point that out. I'm planning to use what I have right there, so it's not a problem. But if you plan to replace it, you need to slide it over this cable all the way up to the switch before you attach this rope. Ultimately, the pull test will tell me, when I pull on both ends, it'll tell me whether or not this is strong enough. Okay, now for my pull test. Got the thing pinned here. I'm just going to pull it as hard as I would feel comfortable pulling it through the conduit. Oh, okay, it just released, so that wasn't strong enough. Well, I just pulled again. I inspected it, it didn't look like anything came loose or whatever, so maybe things are just seating a little bit. I think I'm pretty much set to turn this loose. What I'll do is I'll lay out the conduit cable so that it doesn't tangle on the way down through the hole here. And I'll go to the other end, go to the panel end, and I'll start pulling the rope through. When I'm pulling, what I'm going to definitely do is if I feel any resistance really at all, I'm going to come back over here and see if things are tangled. If you have help, this would be a good time to have help where somebody could help feed the cable down nice and straight, but I think this will work just fine. Okay, here we are. We're back at the panel. The first 4 or 5 feet are just going to be rope that's sitting out on the deck, so I'm just going to pull that a little bit just to get the cable positioned so I can feed it nice straight down into the conduit opening. So I'm just going to pull a little bit. Okay, I'm pulling back. I got about Got about 5 feet. That should do the job. Okay, and as predicted, pretty close. So I'm just gonna stick this down in here, get it kind of started so it doesn't hang up going around the corner and maybe catch on something at the top lip here. Okay, so now I have about 60 feet of rope to pull through, and another hopefully 5 feet of cable will stick out when I'm done. Alright, just for my own sanity, I'm just going to pull like 5 feet at a time. So I'm just going to be gentle, wrap my fingers gently around it, just pull straight up. Okay, that was more like 4 feet. Okay, it's sort of sticking, not totally sticking, but okay, it's coming around. It's not as nice as it was before, but it's still coming. It's still coming. Yeah, man, it's tough. It's tough. It's not as hard as my pull test, but I'd say a third as much as my pull test, which is got me nervous. I'm going to do this with my other hand. I'm naturally right-handed. And I might have a little bit more feel for what I'm doing. Straight through. Okay, seems to have released a little bit. It's a lot easier now. Okay, see all the cable I pulled out. Continuing. It's a little bit sticky now. A little bit sticky. Just got through something, loosened up. It's feeling good now. It's almost completely loose. Still coming. Still coming. Make sure you grab the rope and that's one of these wires. Okay, it's a little sticky again. It's really not full pull test, but it's there, it's close. You just got to have some faith, I guess, at this point. Or the name of an electrician. Because I have no idea how to do this if it doesn't work out. It's not happy going around this corner, whatever it is. Okay, I'm going to switch hands again. Make sure I don't pull too hard. Man, that's really tight. Okay, I'm going to go see if I've got tangles. I'll be right back. Okay, I just came over here to check to make sure nothing's tangled up, and I don't see that at all. So it's hard just because it's hard, that's all. Okay, back we go. Alright, well, it looks like I've got another 15 feet to go, 15 or 20 feet to go. Okay, it suddenly got easy. I don't know why that is, but it's very happy all of a sudden. That's very good. I'm just barely pulling it at all. Maybe half a pound to pull, 1 pound to pull. Okay, this is great. This is good news. Oh, it just hung up again. Okay, I'll just go check the other side. All right, just checked the other side, and it wasn't snagged at all. So I don't know. Last time it got snagged, and then it was fine if I just left it. It's sort of like, you know, it's like it. I don't know. It's really weird. It's like it's wet. All of this is wet, so it's like it gets sort of bound, maybe from friction or something. But then you just let it sit in the water, and it seems to be okay. So just another little bit more to go. Oh man, it's still stuck. All right. Well, it seems to like it when I go back over there and fiddle, so I'm going to go back over there and fiddle. Alright, well, I sort of jammed some of the cable down the conduit at the other end just to kind of prime the pump. It's like it's getting caught way down there. It seems to be fine when I do that here. So it seems like it's catching all the way at the other end, which is not bad news. Not bad news, but on the other hand, it's really stuck now. Alright, well, I'm almost there. I gotta keep pushing. Gotta figure this out. Alright, this time I just pulled an inch or two, a couple of inches from the other end just to kind of pull the rope back down. Maybe that'll help loosen things out up a little bit, get around a corner or two. Yes! Okay, that did it. Helped. Oh, okay. But that's good. I got another 4 feet that way. So, all right. So I guess a little bit of back and forth. I'm going to pull from the other end just to pull this back down an inch or two, and then we'll try again. You know, in retrospect, I should have oiled up the cable or something, make it a little slipperier. But it seems to catch sort of at the end, and that propagates through. But all right, I pulled it out a little bit on the other end. Let me see if that helps here. Success. Success. Now you have to understand how relieved I am, because this was the part that I wasn't sure about the most. We have this cable through the conduit. It's the right cable connected to the new switch. That new switch, I didn't install it the wrong way by cutting any cable. All I got to do now is pull this thing through, leave some extra play in the box here and at the other end, strip these wires properly, connect it to the new connector, plug in the new connector, and this project, I'll put the faceplate on, check everything out, and this project is done. So we are almost done. We're really, the Imperial we is extremely happy with how things are going right now. Well, it looks like we have about 1.5 feet left to pull through. I will leave a little bit of slop at this end, just so that it makes it easier to pry this one up in 15 years when it needs to be replaced. Alright, so the next thing here is to reseal, or to seal in the new switch. I'm just going to run a thick bead around that foam area here and a little bit here, press it down, and call the job done, because this switch is entirely sealed, and really what we're trying to do is keep water from getting down in there, although in view of how the cable was soaking wet when I pulled it through, I'm not sure how much good that does. Okay, so I have some silicone rubber sealant there. I'll take this and work that wire down in and rotate it a little bit just to kind of make a complete seal and call it a day. And I got the positions the way it was before on the other switch, and so this end is done. Okay, so I have finished the switch end. Now the wiring end here. I have what looks like about 6 feet extra, but there's like 6 feet extra of this right here, so I think I'm going to just keep it. And the first thing is to cut this off the rope so that I can get to the wires. Here's my new connector, my workspace. I have it taped into position loosely so that it doesn't go flying when I'm working on it. And up here are my instructions as far as what color goes to which pin. I'm going to strip the wires. I won't show you how I do that. I'm sure there's videos out there that show you how to strip wires, but I'm just going to cut it off here, cut off the jacket, the gray jacket, expose the individual wires, and then strip those about 1/4 of an inch from the end. I don't need a lot of copper exposed. And then we'll wire this thing up. Okay, so wires are stripped, ready to go, and I will install them into this connector now, according to my color chart. Here we are. We have 3 of them in, just to give you an idea. Just do it one at a time, read your chart, take your time. Alright, so at this point you just want to give a really close inspection, because these wires are individually stranded copper, and sometimes an individual strand will kind of stick out and short across. So you want to do a check right after you assemble it, and then you want to do one more check after you've plugged it into the computer board. Just really look this thing over really good, because it's the only chance you're going to get. Alright, so at this point this is wired up. All I need to do is dress this cable into the available space, plug it in, and turn the system back on, and we should be good to go. Okay, I just pushed this cable connector into its slot on the board. Still have a little bit of loose wiring to take care of. I'll do that right now. Okay, the panel is, I believe it's still off. And what I'll do is I'll put the faceplate back on, and we'll do some testing, and it should be fine. Okay, so here we are about 4 hours later. Panel's all closed up. It's powered up. We're in auto mode and it's currently in pull mode. And so we'll do some testing, but I suspect, considering that the switch was working before, it's still working now that it's fully incorporated into the system. So I hope you enjoyed this video. I hope it was helpful. Please do your own pull test. Don't trust my limited engineering on how to connect a rope to a cable. Definitely test every step along the way. But I just wanted to show you, the right way to do it, the best way to do it, the correct way to do it. Maybe you can think of a better way of doing it in detail. But I didn't find any videos like this on YouTube, and I thought, well, this is something that'll probably save you $1,000 if you do it yourself. So here you are. Enjoy. Okay, some last minute thoughts. A whole day has passed. We've tested out the pool and the new button system works really well. I was thinking that this is really sort of long-term thinking, which is it really is annoying to have to replace one of these switches, and I was trying to think of how to make them last longer, and most likely the failure mode, the thing that kills them the most, is just the sun beating down on it during the summer. It gets hot, and the sun of course puts out a lot of UV, and the plastics have UV properties, UV resistant properties, but after a while it's just going to degrade. So I was thinking, okay, well, the first thing, maybe the first thing to do is to consider shielding the switch when it's not being used. So I'm going to show you what I have in mind for that. Probably this is overkill for now, but just a general idea of what I'm talking about. Okay, so this is just a metal bowl that I don't think we have ever used, or maybe we have. But it's something like this. As I said, it's overkill because of how big it is, but that will shield it not only from the UV, but it will also shield it from heat. I'm guessing it will reflect some of the heat. I decided to do some science to find out whether or not placing a bowl over the switch buttons is a good idea. Now this is a thermocouple, temperature sensor, and this is thermometer, electronic thermometer. Now clearly this shield will protect the switches from ultraviolet light, but the question is whether or not it turns that whole area under there into an oven, because if it turns it into an oven, then that's probably not a good idea. So I wanted to know what the temperature would be in indirect sunlight as a consequence of covering the switches with the bowl. So this meter right here, the outdoor temperature is the thermocouple that's inside. So as we can see, the temperature inside is 87 degrees. The temperature out here on the deck is 96 degrees. So it's about 9 degrees different. It's cooler, which is great. That's great. That, as long as it's not warmer, I'm happy. So, I mean, who knows exactly what the temperature difference will be, but it definitely looks as though putting a bowl, a stainless steel bowl, over your switches will block the UV and keep them a little bit cooler. Well, it turns out that I was in such a hurry to replace the switch the other day that I really didn't take a lot of time to have a look at the old switch. Now I believe if I look back at the video when I was prying the old switch out, I didn't actually notice that there's a crack right here. I'm going to have to check the original video to see if it was there when I pulled it out. I didn't produce that crack when I pried it out. I'm sure I didn't put enough force on that. Anyhow, I took this down to the bandsaw to cut the top off, just to get a sense for what the failure mode looks like on the inside. And I just wanted to show you what that looks like. I haven't actually seen it yet, but I'm going to peel this rubber seal off and we can have a look. Okay, so I just cut around the edge here, and the top just fell right off, came right off. So I figure that this rubber seal probably comes off. Yeah, that's not coming off, so I'm going to go get a screwdriver so I can pry it off. Okay, so I have my screwdriver now, and I'm hoping that I can get this rubber cover off without having to wreck it. See if there's anything in here I can see that failed. I really want to know, you know, not just the water got in there, but how did it affect what was already in there. And evidently, oh, there we go. I got it. You see, I peeled it back here. Okay, and I'm taking it off. Okay. All right. So this is just, I had some water splashed on me when I pulled this thing off. You can see some water right here. See some water right here. So this thing goes around a PC board, and these little contact points right here are what push, when you're pushing the buttons, these points push down, and those points push down on these contact points here that probably push metallized Kapton against a metallized surface to complete a circuit. And right around in the middle here, it looks like there's either a bunch of LEDs or just one or something like that. Okay, I'm not sure if this board will come apart. I suspect they have it sealed fairly well, but nonetheless, it's wet. This whole surface here is wet, and you can imagine that it could gradually work its way in between the Kapton layer and the FR4 PC board, that green material layer, and eventually short things out. So I just thought you would like to see what the inside of the switch looks like and get a sense for what the failure might look like. And the apparent cause is this crack right here. I thought, you know, these buttons were breaking down. I'm going to hold this up to the sun and see if there's any light coming through. Okay, I don't know if you can see this, but I'm holding the camera about an inch away from the back side, and you can see there's light getting through the edge of that button. This is the LED opening. Yeah. So yeah, two of these buttons, probably the ones that get used most, those actually were cracked. So if I had to guess, I would say that this crack, and I don't know what would produce this crack. It looks like an expansion kind of feature, as though something got inside here and expanded. Maybe water got inside and froze, although it's kind of unlikely that there's much room for that. But even the epoxy material seems to be expanded out, so maybe it corroded and reacted and expanded in volume inside here, and that cracked it open. Now, whether or not that's where the water came in, maybe that's where it came in, certainly possible, or it came in through these buttons, which is certainly possible, or maybe both. Okay, so this Kapton backing here has adhesive on it. It feels like, well, that's this plastic right here. So there's some sort of adhesive backing to this. I'm going to see if I can peel it off. Okay, well, I peeled it off part way, and what you see right in the middle here, right next to my thumb, is one of the tabs. They're manufactured in such a way they're kind of springy. That's what makes the clicking sound. And when those depress, here's the one to the left here that's still in place. That produces a connection between the outer and the inner ring of the pattern in the circuit board. So anyhow, I didn't find a lot of moisture or corrosion particularly, but when this thing ghosts, it's not like it switches on and stays on either. So anyhow, okay, I think this is enough, more than enough information for those who are curious about how these switches are put together and how they might fail. Okay, well, that's it for today. Hopefully this video shows you a realistic picture of what it would take to replace the switch. If you have any questions or comments, there's a section below in the video where you can write those, and I'll be glad to respond if I have something useful to say. So until next time, if there is a next time, have a good day.